3 a.m. The hangar is silent except for the hum of a failing de-icing pump somewhere deep in the fuselage. You trust the automation, the flight control systems, the integrated avionics, the promised hands-off safety to keep you flying smoothly. But tonight, the promise of modern light jet convenience turns into a nightmare you never saw coming. The industry sells you on simplicity: single-button autopilots, FADEC engines that adjust themselves, fly-by-wire systems that respond to your every touch. Push a button, relax, and let the plane do the work, the brochures say. Elegant interiors, touchscreen panels, fully integrated systems. Luxury meets efficiency. But that elegance hides a harsh truth: these systems are engineered to fail spectacularly when real pressure hits. They trade redundancy for automation, convenience for complexity. And the industry knows it. Yet, they market it as the future of aviation. You climb into the cockpit, the smell of polished leather mingling with jet fuel. Instruments glow. The autopilot engages at a touch. Everything hums smoothly. It's seductive, comforting, and deadly. Because outside the hangar, in real-world skies, a storm isn't predictable. Systems aren't perfect. And failures aren't gentle. The first warning is subtle. A faint vibration from the nose gear retraction motor. Something off about the left aileron feedback. The FADEC system flashes a caution you barely notice. You shrug. This jet is supposed to self-monitor. It's supposed to keep you safe. But safety doesn't come from software, and self-monitoring doesn't fix physics. The broker showed you this jet at the dealership. Gleaming fuselage, pristine cabin, autopilot demo in calm air. See? Single-handed operation. Push the button, relax. Fly with confidence. It was a magic trick. Smooth, effortless, perfect. The systems worked because the plane wasn't stressed. The engines weren't hot, the hydraulics weren't under load, and the weather wasn't angry. Everything was set up to impress. That's the reality the salesman wants you to see. Out here, 40,000 feet above the ocean, turbulence slams the fuselage, tossing the cabin like a toy. The autopilot strains. The yaw damper struggles. Electrical buses flicker under increased load. Systems designed for efficiency choke under stress. And you, the pilot, the owner, realize how fragile convenience can be. Modern light jets promise integrated reliability, but the reality is a complex web of interdependent systems. FADEC engines simplify pilot input but hide a maintenance nightmare. Every sensor, every actuator, every microprocessor is another potential point of failure. One failing pitot tube, one misreading in the angle of attack sensor, and the system hesitates. You fight to understand whether the autopilot is disengaging, or whether it's your own input that's being overridden. Seconds feel like minutes. The hidden trap isn't just failure, it's delayed failure. Modern jets are designed to run flawlessly until they don't. Inspections focus on cosmetic hours, scheduled checks, oil samples, avionics self-tests. But under high stress, these planes reveal the cracks the checklists never warned you about. Hydraulic lines expand under pressure, flight control servos wear faster than predicted, and actuators seize in conditions that were never simulated in the factory. Maintenance manuals bury these risks in fine print. Dealers and brokers never mention them. You reach for the autopilot disconnect switch as the wings start to flex under turbulence. Your fingers are slick with sweat. The stick jerks, the trim wheels fight back. The plane is no longer cooperating. The sleek, intuitive system designed to make your life easier has turned into a trap. You are caught between trusting automation and using raw skill, but raw skill is compromised because you've relied on convenience for so long. Let's talk specifics. The aileron actuators in most modern light jets have tolerances so tight that even a slight hydraulic fluid degradation can increase friction enough to slow response. Bearings, designed for smooth operation under perfect conditions, seize when temperature or pressure varies. Electrical backup pumps may not start in sequence, leaving critical control surfaces underpowered. FADEC algorithms will attempt to compensate, but they are limited by what sensors tell them. One small discrepancy, one misaligned vane sensor or blocked pitot tube, and the system introduces lag where you need immediate action. Imagine the geometry of the situation. Your wing surface moves only a few degrees to adjust roll, pitch, and yaw. The computer calculates torque requirements in milliseconds. Hydraulic resistance doubles with temperature, viscosity changes with altitude, and suddenly the actuator is under 4 times the normal load. The motor whines, electronics heat, and if it fails mid-turbulence, the only backup is your own muscle, but you can't overpower physics. The plane is no longer a machine working for you. It is a mechanical trap holding you hostage in the sky. Even landing gear is not immune. Modern light jets hide complexity in compact electric hydraulic systems. One switch, one lever, and the wheels should deploy. At the show, in calm conditions, it is perfect. Out here, with a crosswind and turbulence, a single jammed actuator locks a strut. The hydraulic pump kicks, the system clicks, and nothing happens. You are minutes from a hard landing. You realize the $5,000 convenience package for powered landing gear isn't a guarantee, it's a gamble. Fuel management offers another trap. Integrated fuel computers promise efficiency and hands-off monitoring. They will calculate fuel burn, optimize mixture, and alert you to low levels. But every sensor is a single point of failure. Blocked lines, misreading probes, or software glitches can misreport levels by hundreds of pounds. In a single-engine jet, that error could mean a missed alternate, or worse, fuel starvation at altitude. The plane doesn't care about marketing claims. It only cares about what actually works when failure strikes. Interior conveniences create subtle risks too. Automated pressurization and environmental control systems regulate cabin altitude, temperature, and airflow. In most demos, they work perfectly. But if a valve sticks or a controller fails mid-flight, hypoxia becomes a silent threat. Luxury and comfort never warned you about that. Dealers rarely mention it. Manuals bury it. You feel the pressure rising, not just in the cabin, but in your own chest. So, what happens when the trap snaps? You are flying manually in turbulence, autopilot offline. Aileron stiff, rudder sluggish, trim unresponsive. FADEC throttles hesitate. Electrical panels flicker with caution warnings. Your hand grips the yoke as sweat drips into your eyes. The jet bucks like a wild horse. Seconds feel infinite. The training you relied on cannot compensate for engineering designed for convenience rather than survival. And the costs compound. One system failure is just the beginning. Repairs are expensive. Replacement actuators, FADEC modules, hydraulic servos, tens of thousands of dollars. And none of it is covered if the failure results from normal wear that was disguised as low hours in the sales pitch. You trusted marketing over engineering reality, and now you pay in dollars, stress, and risk. Modern light jets are beautiful. Sleek interiors, touchscreen panels, autopilot luxuries. Brokers sell the dream, relax, enjoy the ride, let the plane do the work. It is easy to be seduced. But the ocean has a sky counterpart. Altitude, turbulence, system limits, they do not forgive shortcuts. Safety is physics, not buttons. Automation does not replace understanding. Convenience does not equal reliability. Thousands of pilots are caught in this trap every year. FADEC errors at 25,000 feet, landing gear jams, electrical bus failures, autopilot disconnects, incidents that are preventable if the system is simpler, if redundancy is built in, if physics is trusted over convenience. Yet brokers keep selling perfection. Marketing glosses over failure. The reality is hidden until you are alone in the cockpit, fighting a system that was designed for a calm demo, not a stormy night. In aviation, as in life, simplicity survives. Redundant hydraulics, manual trim, mechanical linkages, systems that work when everything else fails. Planes that let gravity and human skill do the work, rather than relying on motors, actuators, or software to save you at the critical moment. You may sacrifice speed, sleekness, or demo elegance, but you gain reliability and peace of mind. Next time you step into a light jet, remember the cockpit at 3 a.m. The plane will not care about your expectations. The autopilot does not negotiate. The FADEC does not compromise. Physics rules, and convenience is a gamble. Choose wisely. Inspect thoroughly. Insist on redundancy. Fly what works when everything else fails. Survival isn't a brochure. It's non-negotiable. If you're considering a light jet, don't trust the demo in calm skies. Inspect every actuator, test every manual backup, and understand the hidden maintenance traps lurking beneath glossy panels. Share your thoughts below. Have you ever encountered a system failure mid-flight, and how did you handle it? And don't forget to subscribe for deep dives into aviation systems, ownership tips, and real-world pilot experiences. The sky is beautiful, but it's unforgiving. Let's fly prepared.